Whoa, Rushi, what are you doing here?
Man, laying like Princess Fiona over here.
No.
What's happening?
Stop.
What are you doing? Rushi, what are you doing, man?
I just came down to play some pool because I don't understand like elastic and elastic collisions. And we have a midterm tomorrow.
Elastic and inelastic collisions. Well, I think I can teach you just by the use of some pool ball.
How can you do that? How can you
Well,
possibly do that?
Before we start, what's going to happen is the transfer of kinetic energy between this solid ball and the strike ball will cause this ball to move, or shift in momentum.
And would
The
it,
transfer of
would it be elastic or inelastic?
I guess we'll have to find out. So the objective of our experiment is to find the velocity at which, so when these balls collide, what velocities these balls are going at, and then eventually from there, with the velocities and the given masses of our standard pool balls, we can determine the momentum and even the impulse or the change of momentum from these balls. So I'll demonstrate quickly what happens. So as you can see, when this red ball collided with this ball, it was an elastic collision, and they moved off at angles. And these angles, as you'll see in a few moments, are especially pivotal to this calculation, as we'll see in a second.
Alright, so after the demonstration, we've collected some data, and basically the initial velocity of ball A hitting ball B was 2.35 meters per second. How we found that was that we found the displacement from the two balls and also the time taken for the first ball to hit ball B. And basically we found that the masses were 0.156 kilograms and the angles were at 40 degrees and 31.1 degrees. And we deemed west and south positive, whereas north and east were negative. And basically our question was that to find the final velocity of the two pool balls, right? So we have to find the x components and the y components. So firstly, we found the x components and we equated the two, and we can cancel this out because the initial velocity of ball B was 0 and it was stationary. And once we found that out, we got our first equation, which was this. Next, we went on to the y component, which uses sine, and we added a negative sign right here because we deemed north as negative, and since one of them had to be negative, and we rearranged the equation and we got VA prime, and that'd be our second equation. Alright, so now that we have our two equations that we got from
Wait, I think I got this. Hold up. I'm getting the hang of this. So we got our two equations. We solved one of them for VA. So VA is equal to 0.8034 times VB, and we noticed that hey, we have VA over here. So I guess we can sub in VA right over here, and when we do that, we can find our VB. So from the VB, we can plug it back into the second equation and get our VA. So the initial ball, the velocity of ball A initially was 2.35 meters per second, but then we can see that after plugging in the numbers, our final velocity for VA turns out to be 1.626 meters per second, and the final velocity for VB turns out to be 2.024 meters per second, and initially VB was 0 meters per second. So is the energy conserved in the pool ball collision?
Well, from our givens from the previous question, what we had to do was calculate the kinetic energy before the collision, and how to determine whether or not energy was lost or energy was conserved. Is you take the kinetic energy before and you subtract it from the kinetic energy after. So when we did that, I calculated it to be decimal 4307 joules, and then the kinetic energy after was 0.206 2 joules, which means that energy was lost, and that's because it was an elastic collision.
Do you know why the energy was lost somewhere in between, maybe because of friction or something?
Likely friction could have been a cause for sure, but it was because it was an elastic collision.
So I guess what I understand from this experiment here is that before, the kinetic energy before was greater than the kinetic energy after. So that means there was energy loss, and so kinetic energy was not conserved, so therefore we can conclude that this was indeed an elastic collision. So it wasn't elastic because for it to be elastic, kinetic energy should not have been reduced.